Okay, welcome to the deep dive. We're jumping into some really interesting new research today, something that might just reshape how we think about teaching robots complex skills.
Yeah, we're looking at this paper about a system called DreamGen from Gear Research. It tackles a pretty fundamental problem in robotics.
Which is?
Well, traditionally, getting a robot to do something new, especially something complex like, say, folding a towel or using a tool in a cluttered space, it's incredibly painstaking.
Right. It often involves a human, physically guiding the robot's arm, right?
Yeah.
Teleoperation.
Exactly. Hours and hours of it sometimes. That's imitation learning. But it's slow, super labor intensive, and honestly, the robot doesn't generalize very well.
Meaning if you change the room layout slightly or use a different kind of towel.
It gets confused, it struggles. The learning is brittle, tied too closely to that specific human demonstration. The real bottleneck is just human time and effort to create all that training data.
Okay, so that's the problem. And this paper, DreamGen, proposes a pretty radical solution, doesn't it? The whole idea of robots generating their own data, like dreaming.
That's the core concept, yeah. What if the robot could bypass needing quite so much direct human input by essentially imagining or dreaming up scenarios and learning from those?
Okay, that sounds fascinating, but also a bit sci-fi. How does DreamGen actually work? The paper outlines, what, 4 stages?
That's right, a 4-stage pipeline. First, you do need some real-world data, but maybe just a little bit, a small demonstration.
It's like one example of picking something up.
Yeah, something simple. And you use that tiny bit of real data to fine-tune these things called video world models.
Video world models. Okay, what are those?
Think of them as the robot's internal simulator, or its imagination, maybe. It helps the robot understand, like, basic physics, how its own body moves and interacts with objects in the world. It's building an internal sense of cause and effect.
Got it. So it learns the rules of its world first, then comes the dreaming part.
Exactly, stage 2. You give this tuned video world model a prompt. Could be an image of the starting scene and a command like, put the teddy bear in the toy box.
Ah, so maybe teddy bears can get involved.
Potentially.
Yeah.
And then the model generates a synthetic video. It's not replaying something it saw. It's imagining the sequence of actions needed to follow that instruction, creating a simulation of success.
So it's basically watching itself succeed in its mind's eye,
Precisely.
even if it's never actually done that exact thing before.
It's generating possibilities. Then, stage 3 is about figuring out the how. It extracts the necessary actions from that synthetic video it just dreamed up.
How does it do that?
Using other models, latent action models, for instance. They translate the pixels, the visual changes in the dream video, into the actual motor commands the robot would need, like move joint A this much, then close gripper.
Okay, so it dreams the goal, then figures out the steps. And the final stage.
Stage 4 is putting it all together. You combine the generated video, the dream, with those extracted actions. This creates what the paper calls neural trajectories.
Neural trajectories.
That's synthetic training data. It's the robot's imagined experience, complete with the instructions on how to achieve it. And that's what you use to train the robot's main control policy.
So it learns from its own generated dreams, not just limited human examples. What kind of results did they see? The paper mentions zero-shot generalization, which sounds impressive.
But it really is. Get this. They trained a robot using human data for just one simple pick-and-place task in one spot.
Yeah.
Just one.
Okay.
Then they used DreamGen to create these neural trajectories, these dreams, based on prompts for new tasks.
Okay.
And training only on that synthetic data.
Let me guess.
That same robot could perform 22 new different behaviors, things it was never explicitly shown by a human. And it could do them in 10 completely new environments. Zero shot.
Wow. 22 new skills in 10 new places, learned purely from its own generated data, starting from just one simple demo. That's a game changer.
Totally shifts the bottleneck, right?
Yeah.
It's not about how many hours a human can spend training anymore. It becomes about how much computing power, how many GPUs you can throw at generating these dreams.
From human time to compute time.
Exactly. And they showed it works for complex stuff too, like folding tasks, even hammering, different robot types as well.
Yeah.
And then, crucially, the more dreams it generates, the better it gets. More synthetic data equals better performance.
They even built a way to measure how good these dreams are. The DreamGen bench.
Right, a benchmark to evaluate if the generated videos actually make sense physically and if they follow the instructions properly. The quality of the dream matters. You can't just hallucinate random stuff. It needs to be grounded.
Makes sense. It still needs to be based on reality, even if it's generating new realities.
Which raises interesting questions. How far can this go? How creative can these dreams be if they start from limited real data?
Yeah, what are the limits of learning purely through simulation? So, thinking about the bigger picture here. If robots can learn complex skills by essentially generating their own practice sessions, their own dreams, what does that mean for, well, everything?
It forces us to reconsider how intelligence develops, how learning happens. Is simulated experience fundamentally different from real experience if it leads to the same capabilities?
And how fast could robots learn in the future if the main limit is just compute power for generating these internal simulations? It really accelerates the potential, doesn't it?
It absolutely does. It opens up a whole new pathway for creating more capable, adaptable robots much faster than before.
Definitely something to think about. Robots learning through imagination. You've just had a deep dive into DreamGen.